Okay, so this video is about just one additional rule to bear in mind if you're dealing with aromatic rings, so basically benzene rings and phenols and things like that. So if we was to do the high-res hydrogen NMR of this molecule, let's label our different environments. So I've got environment A here. We will not have an environment here if we're doing hydrogen NMR because there is no hydrogen there. Remember, if I draw out benzene, like so, each of these carbons is already making 1, 2, and then the ring kind of counts as a third bond, so they've only got one spare bond each. So if you've got a CH3 on that top carbon, look, there's no H's. Same with the Br. So we've only got H's on these remaining 4 carbons in the ring. That's a common mistake people often make, is putting H's there. If you've got a R group, a side group, you won't have a H. But we will have H's here, so we'll have environment B, C, D, and E. So environment A, let's have a look at that then. It is a singlet because it has 0 adjacent hydrogens and 0 add 1 is 1. So singlet. There are 3 hydrogens there, so it will have a relative peak area of 3. And if we look at our handy data sheet, we can see a CH coming off a benzene ring is between 2 and 3. So that'll be somewhere between 2 and 3. So we're going to have a large singlet somewhere like that. I've drawn that a little bit thick, but that's fine. Now here's the rule with benzenes. Yes, we do have 4 different benzene environments here, benzene hydrogen environments. However, the splitting in benzenes is really complex. Because they have this delocalized pi system, they interact with each other in really complicated ways, which are beyond the scope of this syllabus. So here's what I'd like you to do if you see a benzene ring. Just write down all of these different benzene environments as one multiplet. So all of these are going to be a multiplet with a total relative peak area of 4. Now, in reality, it's not one multiplet. It will be lots of different signals, but as they're all so close to each other, they overlap. So it essentially makes a multiplet. It's certainly not something you would need to delve into. And the benzene ring environment, if we look at our data sheet, is between 6 and 8. So although in reality something a bit more complex is going on, what we're going to say for benzene rings is between 6 and 8, we're going to do a multiplet, and we're going to group together all the hydrogens to give one RPA.